Okay, so I'm going to tell you how you can manage big data with BigQuery. First, a quick introduction. I'm Javier Ramirez. You have my Twitter there. You have like any questions, any complaints, whatever, feel free to tweet. And I've been doing software for a while. I'm one of the founders of a small startup called Tiowaki. And we are using Google BigQuery, which is a Google product, for internally for doing API analytics and other interesting things. I don't work for Google. I just have I use their products a lot. I like the cloud. I'm one of the Google developer experts, so I can speak in this kind of things. But everything I say here is my opinion. It's not Google's. But yeah, I'm a user of this BigQuery. And BigQuery is about managing big data. And dealing with big data is usually you need like big servers for having big data. Usually you need like big operations, like people managing the servers, making sure everything is working. If it's not working, replacing the servers, whatever. And this means that usually you need big money for managing big data. And in my case, I'm a startup. I don't have the money, so that was a problem. So yeah, challenge with big data usually is, it's not just expensive, it's also difficult to set up. So in terms of how time-consuming it is to set up a cluster of servers, or you have to learn a lot of things. So traditionally, having big data, it's like, you have to learn a few things. It's not that easy, that's straightforward. And even if it's hard to set up, and if it's expensive, still, in many solutions, it's not interactive enough. You have to run a job, and depending on your data set, a few minutes later, a few hours later, you get the result. And if I want to know something now, I want to know it now. So with some solutions of big data, you can't get this. So big data means different things to different people. The kind of big data I'm speaking today is this kind of big data. It's like being able to have 300 million rows, doing a full scan, a regular expression, getting 200 rows as a result, and having this in about 5 seconds time. That's the big data I'm speaking about today. Because big data means like sometimes, like different things. So this is the kind of thing I'm going to tell you. When I knew I could do this with BigQuery, it was like, yeah, I want to know more about this. So what's this BigQuery? BigQuery is a data analysis as a service system by Google. So it's a service. It means it's there. You don't have to install anything. You don't have to configure anything. You don't have to worry about if Sunday evening the server is down, Google is taking care of that, not me. So that's quite cool. So you basically have to pay for the service. I'll tell you later the prices. But it's a good service. It's based on Dremel. Dremel, maybe you've heard about this, is something that Google is a paper Google published a few years ago about the internal architecture they were using for a few things. Like, for example, for selecting which ads you are going to see when you're using AdWords, for these kind of things. So they were using Dremel. If you are using Google Analytics in any project, so the infrastructure before is also Dremel. So basically, BigQuery is the public interface of Dremel. So it's the same infrastructure Google are using, but with an API, so you can use this from the outside. And Dremel is designed to have interactive queries, so I can ask something and I get the result right away, and over petabytes of data in real time, which is quite impressive. So what you have to worry about when you are using BigQuery? Well, two things. Loading the data and querying the data, nothing else. You don't have to manage anything. Well, and paying for the service. But that's the small print. I usually don't put it here. So yeah, that's the only worry. So that's quite interesting. So first thing, loading data. How you have to load data? It must be really complicated. Not really. For loading data, just send a text file or JSON, and that's it. You send text in comma-separated values or tab-separated values, or basically in any format, or JSON. If you use JSON, you can use nested fields, and you have then some interesting formulas, some interesting functions for dealing with the JSON inside those fields. So that's quite convenient. If you don't need nested fields, you can just send comma-separated values. You send this using the RESTful API or using the client libraries that are for most languages, or even from the command line. you can install something called BQ, which is the BigQuery command line interface. BQ load, name of the file, your project ID, and it's going to upload, and that's it. So that's sending the data. You don't have to do anything else. And if you have like big, really a big amount of data you have to insert, well, you can insert up to 100,000 records per second per project. So it's good enough for most projects. It's powerful enough. If you are having this kind of traffic sustainably, it's not going to be cheap. I can tell you that. But technically, it's going to support this traffic, which is quite impressive. And yeah, you have the data. So right away after you send the load job, a few seconds later, usually, you send to BigQuery, and BigQuery, maybe in 10, 15 seconds, it's going to load the data, and after that, you can already query the data. If you're using the real-time streaming, it's real-time. The second you insert data, that very second you can already query that data. Usually, I don't use it in real-time, but So how you sell it? Well, with SQL. I know it's boring, but that's a good thing. You don't need to learn anything. So these are like real things from my project. Give me all the users. OK, so give me all the users. How many users I have today? How many users I have in the system? Which is the user that registered, like the most recent user? Or how many orders I have by user? So it's quite easy. It's like SQL. And you can make like more complex SQL, like with joins, some subselects, and other things. Other big data solutions, I was evaluating in the past something like Cassandra, some other things. You can't really do those kind of things. So that's also convenient. If you have like different tables, you can join them and you can work with them almost like you will do in SQL. I'll tell you later about this query. I have a slide about this. So apart from the standard SQL, you also have some specific extensions for working with analytical data, like within and flatten. This is for when you have like nested fields, I told you before. So you can just flatten the fields and do interesting things. Or standard deviation, variance, quantiles, correlation. So you have a few extensions. You have also extensions for JSON, extensions for dealing with URLs. So some or with IP addresses. So it's just a dialect of SQL plus a few other interesting functions. And yeah, you can do something like this. There is a public data sample, which is updates to articles in Wikipedia. It has updates for a long time. And it has right now like 300 and something million rows. So yeah, what I'm doing here is, OK, give me all the articles in which do a full scan and do a regular expression and see if I have like any digits on the title. And you get back 200 million results in 5 seconds, which is quite impressive. Why is this fast? Well, first, because it has internally columnar storage. If you've seen any other data warehousing solution or anything at all, instead of using record storage, they use columnar storage. So when you are using SQL, like any database, Oracle, SQL Server, whatever, you can think like, OK, each table, it's being stored on disk. Like a table will be like a single file, not really, but it will be like a file. And you will have like row after another of data. So the users table will be users table, so username, user last name, email, address, whatever, OK? And you will store that on disk. In columnar storage, what you have is the contrary. You store per every column in the database, you are storing a different file. So you have a file for all the usernames, a file for all the user last names, a file for all the user addresses. So one effect of this is those files, you can compress them a lot. If you have a file only with last names, it's really easy to compress. If you have a file only with dates, it's very easy to compress, compared to the other. When you're using big data, the slowest part of the system, get in, come on, don't be outside. So the slowest part of the system is input, output always. So if you can compress a lot, and you can just, have the files much smaller, input, output is going to be much smaller. Also, it's going to fit on the cache of the system. So it's going to be much, much, much faster. And the other thing is in columnar storage, when you're doing analytics, you usually don't want to have all the information from the user. In BigQuery, I don't usually do, give me all the record from the user that registered the last. No. What I do is, give me the total of users that have posted any link in the last 2 weeks. So I'm querying for 2 columns, 3 columns. I don't want the whole record. So that's one of the reasons why it is fast. All the data storage systems, all the data systems, they work like this. Second reason, because it's executing on Google platform, they have like literally thousands of servers. So when I run any query, there is like a decision tree, and the decision tree is going to make, okay, how many servers I'm going to use for this query? 200, 200, I don't care. So that's the thing, you know, you run the query, it's going to be parallelized in different servers, it's going to be aggregated back, and it's going to be sent to you. So by using BigQuery, you are, you know, using like a huge amount of servers every time, even for a small query, usually it's parallelized. But you don't care about that, you know. In other solutions, you have to know, okay, I have only 2 instances, so I have to be careful about this. Here, you know, Google is going to decide, depending how much load they have at the moment in the system, depending your database, depending the columns you are accessing, you are going to get more or fewer servers. That's why it's fast. So this is how it looks when you log into the web console interface. It's like, well, it's not fancy, you know. Google and the interface are never fancy, but it still is functional. It works. So you have like the SQL console, and it's like that. Give me everything I have on my integration environment. Okay, 300,000 rows, whatever. You can do like easy things, like, okay, group the traffic by country. So select whatever, group by country. This is like, you know, what will you do? But you can do this over billion rows. I'll take later example with billions of rows. You have window functions, which is something quite convenient. Window functions are already in most databases, like in SQL Server, Oracle, Postgres, not in MySQL, as I know of. So window functions is, I'm getting the results of which are the URLs most popular by country, and over these results, I'm going to run another operation. So for Germany, this is my most popular URL, and it's 47% of the traffic of Germany. For Spain, this is my most popular URL, and it's 46% of traffic of Spain. So with window functions, you can run operations over the results already. Is this over partition that if you are into SQL, probably you've seen other places. So you can do window functions here. So you don't have to be calculating that on the client side, which is also convenient if you are doing analytics. So, you know, these kind of things are quite interesting. This is like one of my queries. It's like, who is my most active user? Since it's big data, I'm using this for doing analytics. But since I can send like any information I want to send, I'm sending user IDs, for example, so I can single out navigation sensors for individual users. If you are using Google Analytics and you are like a premium user, they let you export your whole analytics data set to BigQuery, so you can run the queries you want from here directly. But this is more interesting. This is not from my project. This is from a project called the Global Database of Events, Language, and Tone, whatever that means. It was published like 2 weeks ago, and it's the largest public data set available worldwide. It has information about events that happen in the world for the last 36 years. So what I'm doing here is I'm asking, okay, from the different events I have, tell me events with different countries, where the country is not blank, and the country is not equal to the other country. So events between 2 different countries, group these events, and tell me for every year which is the most popular event between which country and which other country. And this is the result in 6 seconds. This data set, I didn't tell you, it has 250 million rows. 250 million rows of data. In 6 seconds, you get this list, which is, 1977, China and Vietnam had a lot of events, one with the other. Afghanistan and Russia, not surprisingly, this year, Russia and Ukraine. So every morning at 5 a.m., they are uploading the information, they are updating the information of this data set. It's publicly available. If you open a BigQuery account, you can query the data set for free and do interesting things. In the whole database, they have the URL relative to the event with information. So this is the kind of power you have. So you can query billions of rows in 6 seconds. This is a public data set. If you query billions of rows in 6 seconds in your system, it's not going to be cheap. But if you have billion rows, nothing is cheap. So that's up to you. This is from GitHub. GitHub also have a public data set in which you can query the repositories. And this, for example, tell me the repositories in the Ruby language ordered by pushes, how popular they are in order, how many people are pushing to the repository for the last month. Well, since the 1st of May. And yeah, this is the result. And this was over 26 gigabytes of data, 3 seconds. So, it's quite interesting. And this is actually a real query from GitHub, the trending repositories. So give me the repositories that were created yesterday, and from this query, tell me which of these repositories are being watched by more than 5 people. And it's like, wow, that's cool. Well, that's not cool. That's ugly. I mean, I see this, and it's like, I don't know what I'm reading anymore. Because one thing is having queries, one thing is having the power of running queries over a data set, and the other thing is having information. So in GitHub, for example, this is how the user sees the trending repositories. The real query is the other, but this is nicer, you know, it's nicer. So when I'm working with BigQuery, there are two things. One thing is, okay, the power of getting the data, but then I want to have information from the data. And in my particular case, I didn't want to invest a lot of time. I was considering doing something with R, so getting from the API, getting the results in JSON, and then with R, making like pretty graphics. And then I remember, you know, we're a two-people company. We don't have the time for that. So we thought it would be much nicer if you can just have like a spreadsheet with the data, because spreadsheets are really, with the spreadsheets, it's really easy to have like different graphics. So if I can import all the data from BigQuery into a spreadsheet directly, that would be amazing. And since BigQuery is from Google, and the Google spreadsheets are from Google, I'm sure there is a way of doing this like directly? No. There is no way that you can export directly from BigQuery to a spreadsheet. But there is this piece of information, there is this thing which is like really interesting, AppScript, which is like a subset of JavaScript that is hosted in Google, and you can use this for interacting with all the Google APIs, except for AdWords. So what I did is I have a script that is reading every day from BigQuery, creating a spreadsheet on my Google Drive, emailing it to me every day. So every day, 9:30 in the morning, which is like 30 minutes before I wake up, I have the information about, okay, how many new users you have, how many users are using the system, how many things are active. So I get that information just, you know, with the scripting. And it looks quite easy. Doing a script in BigQuery, in AppScript, sorry, you do it all in the browser. So my main script looks like this. It's like, okay, get my folder in the Google Drive. If it doesn't exist, create the folder, create a new spreadsheet, populate the new users, populate the deleted users. That's about it. So the script is quite easy. Then sending the email for interacting with Gmail with AppScript is as easy as this. This is sending an email to Gmail. So just, you know, get the data of the body, send this to these addresses, this is the subject, this is the HTML, send it. So if you want to automate your Gmail inbox, you can use AppScript for analyzing your Gmail, doing whatever. So, you know, it's quite powerful. And this is actually the script I use for doing the queries. So, yes, you know, I set the BigQuery project ID, I put here the query, I send the query to the server. Since this is asynchronous, I send the job, and I keep waiting until I get the result. When I get the result, I compose all the results in an array, and that's about it. I'm going to open source these 3 scripts in the next, so if you follow my Twitter, in the next week, I'm going to open source this if you want to play with BigQuery and Drive and Gmail. So I'll put this on GitHub somewhere, so you can just take a look. And maybe you're telling me, yeah, it looks quite cool, but you are telling all the time that it's going to cost me money. Yeah, it's going to cost you money. This is the price as of today of BigQuery. Per each stored terabyte, sorry, you are going to pay $26, which in pounds is like nothing, but anyway. So for our first million rows, this is what we were paying. So, you know, it's like, if you have like billions of rows, you have like, you know, hundreds of million rows, it's expensive. But a million rows, this is what it costs per month. In pounds is this, which is, you know, yeah. And then per processed terabyte, which is how many columns you are reading. So for the columns you are reading, in each query, you are paying 2. But the first terabyte of data, it's for free, for querying, not for storing. So effectively, I'm not paying anything for querying my data set, because there is no way with my data set, I have like 10 million rows now. There is no way I'm going to be doing more than 1 terabyte of queries every month. But yeah, that will be the price. Considering a full scan over 1 million rows is 5 megas, until you get to the 3 terabyte, you know, you can do a lot of full scans. And AppScript is totally for free. So this is effectively, for the first million rows, the first month we were running the service, this is what we were paying. This is with our data. Our data is like log files, so Apache log files. If your data set looks like log files, like a user agent, IP, URL, query string, status, blah, 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 blah. 1 million data, 1 million rows is going to cost you this. If you have more data, it's going to cost you more, but so you can get like the ballpark. So this is what it cost me for each million rows, which is sensibly cheaper than the cheapest server I can get. Cheapest server I can get at the moment, reliably, for me is DigitalOcean. I'm paying $5 a month. Until I get $5 a month, I can store a huge amount of million rows. And anyway, with a server of $5 a month, I wouldn't be able to have big data. So to me, it's quite a big situation. And for me, at a startup, even if sometimes when I'm thinking of big things, I feel like kind of my underwear, like having things like hosted solutions, like cloud services, like BigQuery in this particular case, makes me have the possibility of doing more powerful things than I thought. That's what I have. If you want to have related links, I have a URL there. So when they publish the slides, you can just go to the URL for more links about big data and BigQuery. And if you have any questions, I'll be glad to answer now or later. I'm going to be in the Google stand. If you want to have like $500 for free or BigQuery, they are like or cloud services in general. There are some coupons on the stand, so you can come see me later or ask a question now if you want.